Alright, we're going to continue with integration by substitution. You should not even begin this lesson unless you've worked on the last homework assignment because it's just continuing on, except we're going to have trig functions in there. It's very important that you have done most, if not all, of the other assignment before starting working on this one. In this example, what we have is typically we're looking for where those parentheses are. Well, there's no parentheses here. We just have to recognize the parentheses as being after the sign. So if we have one trig function, typically we're going to pick what's after the sine, cosine, tangent, whatever happens to be there. So I'm going to go ahead and pick my u to be x to the fourth, which makes my du be 4x cubed dx. So I'm going to be able to rewrite this as the sine of u, and I need exactly a 4x to the third dx, which is what I have, and I'll just write a du here. So when I integrate this, I end up getting negative cosine u plus c. So this ends up being my final answer. Next example, we have the same type of scenario. We're going to go ahead and pick what's after the sine to be our u. So our du is 2x dx. So the difference in this problem is that I only needed, when I rewrite this, the sine of u, I only need an x dx. So that's right here. So I'm going to move my 2 to the other side. So that means if I replace the x dx, I need to replace it with a 1/2 du. So now when I integrate sine of u, I get negative cosine of u plus c, and then I'll just distribute my 1/2 through for my final answer. In my next example, I have two trig functions, but this isn't one where I need to think about choosing one of my u's to be an actual trig function because I know what the integral of sine of u, tangent of u would be. So I'm going to pick my u to be 1 minus x, which makes my du be negative dx. So when I rewrite this, I get secant u, tangent u, and I need only the dx part. So I'm going to say that dx is equal to a negative du. So I'll put a negative du to replace my dx, and then I'll integrate. Well, the integral of secant tangent is secant, and then I'll have my plus c, and I'll replace my u value with my x. And I just realized I did not do that on the last examples. So I'll go back up and make both of these. I should have replaced my x values, so that is to my x values. That's completely my fault, and this is my final answer. So I need to get rid of that part. And this one right here, again, we needed to replace it, so that was in terms of x. So this right here would be my final answer. I'm sorry about those. That's one. Go back and put those x's in. I just showed that. On this one, we have two trig functions, and I don't know the derivative or the integral of tangent x, secant squared x, so I want to think about which one would I pick to be u so that when I took its derivative, it would go away. And that answer, that would be tangent of x. So if I take the derivative of tangent x, I get secant squared x dx. So that's going to let me be able to rewrite this as the square root of u, so that takes care of this part, and then I need secant squared x dx, which is exactly what I have by putting a du here. So now I have the integral of u to the 1/2 du. So I'll raise this by 1 and put it over that power, and I'll have plus c. So I end up getting 2/3 u to the 3/2 plus c. So that gives me my final answer once I plug back those x values. I won't forget that again. Of tangent x to the 3/2 plus c.